Hello, algebra students, pre-algebra students. Today we're covering 9.2, prime factorization of greatest common factor and least common multiple. Please put your name and date on your notes. Your learning objectives today are to write the prime factorization of composite numbers, factor monomials, find the greatest common factor, the GCF, and find the least common multiple, which is the LCM. A prime number is a whole number that has exactly two unique factors, 1 and itself. A composite number is a whole number that has more than two factors. For example, 6 is composite because you can get 6 by multiplying 1 and 6, but also by multiplying 2 and 3. Then 8 is composite as well because you can multiply 2 and 4 to get 8, and 1 and 8 to get 8. But 5 is prime because the only way you can make 5 is by multiplying it by 5 and 1. So this one is prime, and these two are composite. All right, so for example 1, it's asking us to identify prime and composite numbers. So to do that, we have to list the factors. So does 15 have factors other than 1 and 15? So we'll start with 1 and 15, and then we'll make a list. So then we have 3 and 5, and that's it. For 23, I can have 1 and 23, and I can't think of anything else, so that means it's prime. So for number 1a, this would be composite. And for 1b, that would be prime. Let's pause the video and do 1c and 1d. So here's a chart of some examples of prime numbers and composite numbers. You can see that they've listed the factors. Next, we're going to talk about the prime factorization. The prime factorization of the number is when the number is written as a product of all its prime factors. And so we want to make a factor tree. You can see that I put that in your Cornell notes in the thoughts and questions section. So for 35, I would multiply by 5 times 7, and those are prime numbers, so I can't factor 5 and 7 any further. So the prime factorization is 5 times 7. For 24, I can multiply 12 and 2 to get 24. And then 12, I can factor further as 2 and 6. And I can factor 6 further as 2 and 3. Now I'm finished, and so all of my factors are 2, 2, 2, and 3. That's how you write the prime factorization. So because 2 is prime, 2 is prime, 2 is prime, and 3 is prime. Let's pause the video and you can complete the factor tree for 100 and write the prime factorization. Get ready to turn your page. Now let's talk about monomials. A monomial is a number, a variable, or a product of numbers and or variables. So for example, 80 or x or 8x are all monomials. They're not monomials if you're adding them, so x plus 5 or x squared minus y squared. Let's see how we factor these. 10 is 2 and 5. So we would write this as 2 times 5 times x times y. That would be the prime factorization. 12 is 2 and 6 is 2 and 3. Q squared is q times q, and r cubed is r times r times r. So now we're going to take all of these prime pieces and put them as an expression where we're multiplying them all out. Okay, so we're going to pause so that you can do 3C, and we'll talk about the negative. Don't worry too much about it. It's just going to come out as a negative, whatever your first number is, or you can factor it out as a -1. All right, so try C and then we'll talk about it. Let's talk about what the greatest common factor is. The greatest number that is a factor of 2 or more numbers or monomials is called the greatest common factor. There are two methods for finding the GCF. If the numbers are small, you can list the factors, and if the numbers are large, you can find the prime factorization of each number. So let's try this for 6 and 8. Factors of 6 and 8 are 1 and 6, 2 and 4. Factors of, 2 and 3. Oops. 2 times 3 is 6. Factors of 8, I think I was thinking of 8 when I said that. Factors of 8 are 1 and 8, 2 and 4. So when we look at this list, we want to find the factor, the greatest factor that's the same. So 1 is the same, but that's not the greatest because 2 and 2 are the same. So the GCF of 6 and 8 is 2. Let's do that for 1b. These numbers are a little bit bigger, so I'm going to list the prime factorization. So for 9, it's 3 times 3. For 15, it's 3 times 5. And for 24, I'm going to draw my tree upside down. We have 2 times 12, and we have 2 times 6, and we have 2 times 3. So they all have a 3 in common, and that's the only thing that they all have in common. So the greatest common factor is a 3. Okay. For 1C, I can factor these into 2 and 6, and the 6 is 2 and 3. Then I have an x. So we would write this as 2 times 2 times 3 times x. For the 40, we would have 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. And then I have an x squared. So the prime factorization would be, for 40, I'm going to write it above because I have more space, 2 times 2 times 2 times 5. We can check that. 2 times 2 is 4, times 2 is 8, times 5 is 40, and then we have an x squared, so times x times x. That is the prime factorization for 40, or for 40x squared. Okay, and the prime factorization for 12 was 2 times 2 is 4, times 3 is 12, and then we have the x. Okay, what do we have in common? So there's a 2 in common, there's another 2 in common, and there's an x in common. Now if we multiply 2 times 2, we get 4, and we multiply by x, we get x. So the GCF is 4x. Okay, this next part says the least of the non-zero common multiples is called the least common multiple. So we teach these together, but they're a little bit different. Greatest common factor and least common multiple. When we're looking for the least common multiple, sometimes it's helpful to start with a factor tree. So I'm going to do the factor tree for 120. So I'll start by dividing by 2, and that gives me 60. And I can divide by 2 again, 30. And then I can divide by 3 and get 10. Then I can divide 10 into 2 and 5. So now I could write the prime factorization. So the first thing we do is factor tree. Second thing we do is prime factorization. So we have 2 times 2. I'm going to go ahead and put the next 2 times 3 times 5. Okay, that's just for 120. Now I need to do the factor tree and the prime factorization for 180. So I'll divide by 2 and I get 90. Divide by 5 and 12, 18. And then I'll divide that by 3 and get 6. I'll divide that by 3 and get 2. So then I'm going to write the 2's first. So 2 times 2. Then I'll write the 3's. 3 times 3 times 5. That is the prime factorization of 180. So for 2's, the greatest one that we have 3 of them here. So we want to choose the one that has the most. But we also have these 3's. And then we have a 5 in each. We only have to use one of the 5's. Circle all the unique factors. And then write the product of those. Okay, so we have, I'm just running out of space here. We have 2 times 2 times 2 times 3 times 3 times 5. That equals, so this would be 8. This would be 9. And there's 5. 5 times 9 is 45. And 45 times 8. I'm going to do that over here. And if you have a calculator, you could totally use a calculator for this. 8 times 4 is 32, plus 4 is 36. So our our LCM is 360. That is our LCM. I want you guys to work in groups to figure out the LCM for 30 and 18. Now we are looking at variables, and so the exponents can really help us actually, because if you have an exponent, you're going to use the one with the highest exponent in your least common multiple. So your least common multiple has to have an a to the third and a b. Okay, so we'll just keep that in mind. And then for 24 and 30, that's going to be 6 and 4, and 30 is going to be 6 and 5. We could keep going, but since I see that the 6's are in common, I can just use those as part of my least common multiple because I know that we have to have a 6. So my least common multiple is going to have a 6, a 5, a 4, And then we're going to use the highest exponent, a to the third and b. Then we're going to multiply this out. 6 times 5 is 30. 30 times 4 is 120. A to the third, b. That was a little bit quicker, actually. And then we're going to pause the video, and then I'll have you do D. We covered a lot of material today, so I want you to go back and review what we just covered in the notes, and then I want you to write a sentence in the summary. When you're finished writing your sentence, share it with somebody and see if they wrote something different. If they did, then you can write what they wrote in your summary and they can write what you wrote in their summary.